Okay, so continuing to go through Math 3 Classwork 4.1, as I'm subtracting my polynomials, I would recommend, let me write this out and then I'll show you what I recommend. Anytime I'm subtracting with a parentheses, I change it to addition and then just change all the signs throughout. And it is helpful if you line things up. So I'm trying to add x plus 5 with this longer polynomial. I'm going to put x minus 5 where the x is under the other x term and the minus 5 is under the other constant. And I turned that subtraction into addition. So now I'm just adding these two. Bringing together my like terms, I've got those come together to make -4. These come together to make minus x. And the other terms are just there. And they stay. So it's not too bad when you're adding polynomials or subtracting polynomials. And then one last problem that I want you to try on your own. See if you can do the addition of g plus h, and I'll give you a minute to look at that and do the addition yourself, and then check to make sure you're doing it okay. So what I would do is I would take these three terms of g of x and write them underneath the like terms of h. And that'll make it a lot easier to see what is being added together. The constants add up to 3. The terms with x add up to minus x. And the negative x squared is a loner, and 2x cubed plus 1x cubed gives you 3x cubed. And then you've got, voila, polynomials have been added. Now, you've done multiplication before, but we need to go over it again. Know that standard form means you have your largest exponent first on the left side, and then it decreases. And that's the way that I've written all three of these answers, is the largest degreed term first, and then it goes down. But if it doesn't have, say, an x squared, then it just skips it and goes down to the next one that is there. So, a little bit of multiplication practice. Now, if you line things up really nicely, you can avoid the mistake of accidentally adding terms together that are not like terms. But when you do it, you want to make sure that you have a line for every exponent, even if the term isn't there. So this one, number 4, is no problem. I'm going to go through and just do that one. But number 5, there will be something to take account of. So I'm just going to write along the side x squared 3x minus 1. And it doesn't matter who you make go down versus across. The other polynomial, I want to keep it in order. The x squared, the x, and then the constant. And then multiply for each box. So for this one, we're multiplying 2x squared times x squared. And x squared times another x squared gives us x to the 4th power, multiplied by that 2. For this box, we are multiplying the x squared and the negative 5x, and that will give us negative 5x cubed. And I'm pretty sure you get the idea, so keep going. You do the multiplication. I'll keep writing it here. X squared times negative 1 3x times 2x squared, 3x times negative 5x, and 3x times negative 1. And then the last row, negative 1 times 2x squared, negative 1 times negative 5x. I'm overemphasizing the positive, and negative 1 times negative 1. Once you do all of the box multiplication, you're adding like terms, but this is set up to be able to add the like terms more easily. In the upper left corner, you see the largest exponent you're going to see from the multiplication. Then when you go to the diagonal underneath that, so I'm hoping you see what I mean by the diagonal underneath the box highlighted in yellow. That is going to be one exponent smaller. So that was x to the fourth in yellow. The blue is all of the x cubes, and it's all of the x cubes, and you can just add them up. Then when you go down to the next diagonal, you see all of the terms that have one exponent less the x squared terms. They add together. And, then it continues. Add those, and then a loner. Adding them together, 6 minus 5 gives me positive 1 x cubed. Negative 2 minus 15 minus 1 takes me to negative 18 of the x squareds. And then positive 5 plus negative 3, positive 2, and loner 1. And it's simplified automatically if you use this process. Now with number 5, it may seem a little bit annoying to do what we're going to do in number 5, but I will tell you that I have come to realize how valuable it is in the long run. And you can put your zeros in however you want to do your zeros, but let me show you that with x cubed minus 5, it helps, and it helps to line it up where the next exponent down is x squared, but I don't have an x squared, so I leave a 0x squared there. The next exponent down is x to the 1 power, but I don't have that, so I write a 0x. And then I finally have the constant minus 5. Realize that if you put those zeros in, it allows this process, this diagonal lineup, to happen every single time. And what's going to make this even more useful is when we have to do polynomial division later on in this chapter. When we go through polynomial division, it's harder than just regular factoring. But if you line things up, putting in lines for where there is nothing, you will continue a really nice pattern that you can follow. So I want to let you know that even though it's tiresome to do the zero lines, they are valuable in the long run. The second factor that I'm multiplying is x squared plus 9x minus 8. And that has the x squared, the x to the 1, and then the number. Then when I multiply, I go like normal, x cubed times x squared, add the exponents, x cubed times 9x, and x cubed times negative 8. Now, if you look at row 2 and row 3, you are multiplying by 0. Now, if you look at the fact that you have an x squared times an x squared, there's an emphasis on the fact that this is 0x to the fourth, adding with the 9x to the fourth in its diagonal. I'm getting 0 throughout that whole row and throughout the next whole row. I'm not going to make you do this, but I just want to emphasize the technique. For this spot, I have 0 with an x squared times an x. For this spot, I have a 0x squared times no more x's. For the next row, I have 0x times x squared, 0x times 9x, and 0x times a number. And I just want to emphasize that this allows the lineup. Which means less errors. It's really frustrating when we make those really simple errors. This box method really helps to prevent some of the most simple errors that, we don't like to do. Anyway, finally, I need to do some work in the last row. Negative 5 times x squared, negative 5 times positive 9x, and negative 5 times negative 8. Then it's a matter of, like I said, just lining up the diagonals. And you should notice that the upper left corner is going to be the term with the largest exponent, and the bottom right corner is going to be the constant that isn't multiplied by any x's. So write the addition of everything inside the box. You have x to the fifth plus 9x to the fourth. Along the green diagonal, I only have minus 8x cubed. Along the yellow, I only have negative 5x squared, and then negative 45x, and finally plus 40. I will tell you that you do not have to use any particular technique. You can, if you have another way to do math problems, feel free to use that technique. I think that is really important that you have the freedom to choose the technique that works best for you. I will tell you that over time, I have seen why this box method is actually helpful in the long run. All right. Now, let's keep going. We've got more to do. So I want you to take a moment to get this set up and see if you can get this multiplication done. I'm going to pause the recording. So here are the answers on numbers 6 and 7. I want to point out that there was no x squared right there where I highlighted. So I put a placeholder of 0x squared. It allows for everything to line up really, really nicely when that's done. So I can see who is x to the fourth to add together. And when I've got this many x cubes to have to add together, it's definitely nice to have it lined up like this. And then does anyone have any questions on these two problems? Are you ready for me to keep moving forward, or do I need to pause a moment? I will take no response as I should keep going unless you say something. So next is dealing with factoring. And there's a very, very important first rule of factoring. And that is you are looking across the terms. Now, when I say term, I mean in between addition, subtraction. Number 8 has 2 terms. Number 9 has 3 terms. Number 10 has 2 terms. So as you look at the terms, you want to see if there is something that will divide all of those terms. You're looking for a common factor, and you want to factor out any common factors before you go forward. One thing that's nice is you have done a lot of work with second-degree polynomials where you have an x squared and an x and a constant, or maybe just an x squared. You've done a lot of work with that, and you want to grab a hold of everything you understand from when you were working with, excuse me, when you were working with those parabola equations, because we are going to grow from that base. We're taking this further and looking at higher degree polynomials. We're going to be graphing them, which is really fun. And then also looking at the algebras specifics. So in number 8, what you want to notice is both of these terms can be divided by an x cubed. So you're thinking about what can I divide both of these by and not have a fraction. So if I'm factoring that common factor out, realize that what is left over is what results when I divide by that x cubed. So if I have 4x to the 4th divided by x cubed, that's going to leave me with 4x. And then I bring the minus sign down, and x cubed divided by x cubed is just 1. When you've factored out a common factor, look at what's left over. If what's left over is a linear like this one, you are done factoring. When we're factoring, we are trying to, as much as possible, get it down to linear factors, like what you have done before. When you factored things, you got things like x plus 2 times x minus 3. So you're looking for an x plus a number. Once you have that, you're done. Number 8 is completely factored. All you needed to do was pull out the common factor, and that was the furthest you could go with it. For number 9, what do you notice can divide all 3 terms in number 9? Let me see an answer in chat so that I know that you're all actually there with me. I'm waiting. Somebody's typing, right? You're still confused? Okay, that's fine. That's what I need to know. I need to know, does it make sense what I'm telling you? Do I need to re-explain? You are looking at what can I nicely divide by, and it'll actually cause, what I'm dividing by to, I don't want to create a denominator. So what you want to see in number 9 is that you have an x to the 4th, you have an x cubed, and you have a 20x squared. When it comes to the x's, the smallest amount that you have on any of these 3 terms is 2 x's being multiplied. You have an x squared. So if that is the smallest exponent that I have is x squared, that's what I want to be factoring out. And realize that when you have the x squared with that parentheses that I just wrote, that what comes inside that parentheses is whatever is left over after I do a division by x squared. Because I need, for whatever is in this parentheses, I need to be able to multiply that by x squared and get what I began with. So this is as close as you're going to get to division for a little while. We did addition and subtraction, then we did multiplication, and now we're doing division by factoring, and later we'll see a bigger division process. So we have x to the 4th divided by x squared left over, minus x to the 3rd power divided by x squared leaves me with 1x when those two are divided, minus 20x squared divided by x squared leaves me with a 20. I want to look at the result, what was left over after pulling out that common factor, because often from there you can factor further. Compare the 2 blue highlights and notice 4x minus 1 is linear already. But the newest highlight is a quadratic, and we can factor quadratics a lot of the time. And so we are going to have to go a step further. I want to keep the x squared that I factored out. It didn't go away. I've got to keep it. Then I want to set up my 2 parentheses for factoring x squared minus x minus 20. And I'm going to go through the factoring with you. You can create first the diamond, where the top of the diamond is a times c and the bottom is b. And let me just write this out to make sure you're clear what's a, b, and c. So a is understood 1. C is negative 20. Make sure you bring that negative sign with it. One times negative 20 is negative 20. And then b is the number x is multiplying by if this is addition. So I need to see that it's negative 1 for my b. And now I'm trying to think about pairs of numbers that multiply to make negative 20. That's my focus. Numbers that multiply to give me negative 20. For example, 2 and negative 10 multiply to make negative 20. But if I add 2 plus negative 10, I'm certainly not getting negative 1. So with that thought, try for another pair. Maybe you go from 2 to 4. 4 times negative 5 gives me negative 20, and oh my goodness, when I add them together, I get the negative 1. That is the pair. This allows me to know how I'm splitting the negative x up Because remember, when we're factoring, we're actually doing division. And when I'm doing division, I'm going backward on my box multiplication. Inside the box, I need to be getting the result of multiplying the two factors, the x squared minus x minus 20. And the way we have the boxes set up is the largest exponent term goes in the upper left corner. The constant goes in the bottom right corner. And the diagonal in between those two is the x term. And this is the pair of numbers I want to use for the x term. Positive 4 times x and negative 5 times x. That will be the winning pair that's going to help me get through this. So inside, everything adds up to get this polynomial that I'm trying to factor. Then, similar to that first rule of factoring, I am looking at whatever I put here. I need to be able to have that be a common factor in that column. So I need something that will divide nicely both the x squared and the 4x. And the only thing that will do that is x. So I'm going to take those out and put in x right there. And once you get it started, it can go on a roll from there. X times whatever goes here has to give me x squared. So that means x. And then x times whatever goes here has to give me 4x. So that's going to have to be a 4. And now I come over to, for this box, I need to multiply x by something to get negative 5x. That's going to be a negative 5. And the last bit is to check that I get the right constant term. Negative 5 times 4 gives me negative 20. That worked out. So I have it. Now, if you're able to factor faster than this, go for it. I wanted to go through this because I know there are a lot of people out there who struggle with it. Oh, yeah, don't worry about your computer dying. For me, this morning, I had to leave my class and restart my computer to get it to work. It's something we're all dealing with. Don't feel bad. Okay, and then at this point, I have what I was first able to pull out as a common factor, and then what was left over, I now have only linear factors, and I'm done. Well, are we seriously only at 10 minutes left right now? Because, wow. All right, anyway, keep going. Next, I only have 2 terms. You want to look at what will divide both terms and not create a fraction. And that would be x. So that means that x that I found will divide both of them. I'm factoring that out. And that will leave left over x cubed divided by x. And then 9x divided by x being subtracted. And I want to look at what is left over. It is not linear. So if I'm able to factor, I need to keep going. You want to notice that it's a difference of squares. It's an x squared minus a 3 squared. Difference of squares factors into a pair of conjugates. X is being squared, and 3 is being squared. And now I have 3 linear factors altogether. And I'm done. Okay, and then I have 2 more examples. If I can get it to come back, there we go. My computer is having lag time problems. All right, so factoring some more. This time, I want you to focus on the numbers. You have a 2, a 4, and a 30. What can you divide all 3 terms by? Right. They're all even numbers, so let's divide all of them by 2. That means that I am factoring a 2, so I want to write that down, and then just look at what's left over when I divide. X squared plus 2x minus 15. And then I'm again needing to factor a quadratic. And this time I'll go a little bit faster. Actually, I'm going to do it this way. If you have just a 1 coefficient, then that makes factoring a lot easier. You're going to have to multiply a leading x and a leading x to get that x squared. After that, you've got to figure out whether it's adding or subtracting and what numbers to make this happen. If you've got only a 1 there, you can focus on these numbers need to multiply to make negative 15 and add to make positive 2. And maybe I don't need to go through the whole box division that I showed in the earlier problem. And thinking about it, negative 5 and positive 3, they'll multiply to make negative 15. But when I add them, I get negative 2. So that's not the right way. If you see that when you're adding, you get the opposite sign, change the signs. And that is really telling you what these numbers need to be. These numbers need to be a plus 5 and a minus 3. And then if I wanted to check, I could do the box to make sure. And we've got factored. With the last problem, I want you to see that sometimes you can divide by the variable and a number. You should see that you can divide all 3 numbers by 5. You should also see that every one of these terms has an x, but the smallest exponent there is a 1, so I only can divide by x to the 1 power. So I'm dividing each term by 5x, but when I write the factoring, I have 5x multiplying by what's left over from doing this division. So that gives me 2x squared minus x and then minus 1. When I go to factor the quadratic, it's not quite as nice. Maybe you see it and you can write it down and you're good to go. You don't have to show your work with factoring if you're able to do the factoring in your head. If you're having difficulties, I'm going to talk you through it. So a times c is negative 2. B is negative 1. I need 2 numbers that multiply to make negative 2, but when I add them, I get negative 1. And that pair of numbers is what's going to work. But if I want to figure out exactly how the factoring goes, I really need to look further at the box. Now, I'm focused on This is who I'm factoring. My highest degree term is 2x squared. It goes here in the upper left box. The constant -1 goes in the lower right box. And this tells me how to split up the negative x. It will be split up as a -2x and a +1x. Then whatever I put here needs to be able to divide both 2x squared and -2x, and 2x will do that. Then I'm on a roll. I need to figure out what this is. By knowing 2x times that gives me 2x squared. It's got to be x. For this spot, 2x times what is -2x? So -1. And then I'm almost done. Over here, x times what is x? 1. And double check, -1 times +1 does give me that last corner. This is how it will factor. It does not matter what order you put these parentheses in, but that there is factored. So make sure this unit, we're going to do a lot of factoring, and I've been trying to give you some factoring leading up to this. It is very important that you become good at factoring at this point. So if you need more factoring help, I would advise maybe go to Khan Academy or your favorite math person and make sure to get some help with factoring over the weekend if it's something you struggle with. And oh, what? Weekend? We're almost there? Yeah. Who's happy about it? Yeah. Yeah. And, you know, treat yourself this weekend. Treat yourself. Be nice to yourself. Something that sometimes helps when we're dealing with this difficult situation is just laugh at it. Sometimes when I'm just really getting frustrated with the situation, I'll go find what comedians have posted about what's going on right now, and it helps me to just laugh at everything. And it makes a big difference. So take care of yourselves. The number one most important thing for you to do right now is take care of yourself. Be kind to yourself. And have a good weekend, and I will let you go 1 whole minute early. Huh? Actually, it's less than a minute. So I will see you on Monday.